everyone. Very good morning. It's my immense pleasure to explain our project and whatever the experience we gained in this project to you all. The project title is an empirical based intelligent safety approach for reducing two-wheeler crashes in urban area. The project theme is transportation engineering. Actually, this project is funded by the Institution of Engineers India, Kolkata. The project ID is TR 2024-003. So myself, Sandhya, full-time research scholar, Department of EEE, Comrade College of Engineering and Technology, Virudhunagar. My principal guide is Dr. B. Gurukarthik Babu, Assistant Professor, Department of EEE, Comrade College of Engineering and Technology, Virudhunagar. And my co-guide is Dr. D. Prince Winston, Professor in Head, Department of EEE, Comrade College of Engineering and Technology, Virudhunagar. So this is the presentation outline. So the first one is motivation and introduction about this project, and second one is problem statement, and followed by project abstract and objective, block diagram and flowchart, hardware requirements, testing and calibration, result and discussion, and finally conclusion and references. Let's see the motivation and introduction behind this project.
Presently in our country we are facing two important challenges. One is road accident and other is air pollution. Fortunately, our ministry is responsible for that. Every year we have 5 lakhs accidents and 1,50,000 deaths. Every day 1,100 accidents and 400 deaths. Every hour 47 accidents and 18 deaths. That the family which are facing the problem because of the death of their young person from their family, it is really, I cannot explain it in the world. And this is the time that we have the highest priority for this, how we can save the life of the people. And road safety is the most important thing for that.
Two-wheelers accounted for maximum fatal road accidents with 44.5% of the total cases. The majority of the deaths due to two-wheelers accident were reported in Tamil Nadu.
It is important to note that Tamil Nadu has reported the maximum road accidents, becoming the highest state in the country to record road accidents for the 5th consecutive year in 2020. And unfortunately, two-wheelers comprised of the highest share in accidents and fatalities for the 2nd consecutive year in 2022, amounting to 44.5% of the total accidents caused in the country. 50,029 persons killed were not wearing helmets and 16,715 persons were killed who were not wearing seat belts. So what is being done to reduce these cases in the future?
This is the problem statement from the introduction of this project. So we identified these problems. So the first one is need technological improvement of road safety, especially for two-wheeler users. And also, most of the past research articles focus on pre-accident alert system and post-accident reporting system separately. And the next one is there is a lack of automatic accident database management system, thereby inaccuracy in preparation of accident report. It will impact the actions against the road safety. And reporting time for medical emergency taken should be reduced. And prototype testings for the safety features are missed for small engine bikes as well as bicycles. And also, there is inflexibility of using smart helmet system due to improper placing of sensor modules in the two-wheeler. So it's a time to think about road safety for the two-wheelers. So we framed the objectives to overcome these problems. So this is the project abstract. So our project consists of 3 phases. The first one is pre-accident alert system, and second one is post-accident reporting system, and third one is automatic road accident database updating system. So the first one is pre-accident alert system. It gives the distance-based pre-accident alert as well as drunken drive warning system. And post-accident reporting system, when a person met an accident means it gives the SMS alert automatically about the accident details with the trusted contact person within the 5 minutes. And third one is the current road accident details management system is done in manual process. So we automate this process to improve the accuracy of the road accident database management system. So this is the objective of a project. So the primary objective of this project is to develop accident prevention model by designing the pre-accident alert system, post-accident reporting system, and third objective is automatic road accident database updating system. So all these three objectives are implemented in real time with the empirical based analysis. So that is the fourth objective. So in pre-accident alert system, when a vehicle reached too close to it means it gives the pre-accident alert warning to the driver, as well as when a driver met an alcohol consumption and try to start the vehicle means it gives the alert. So before starting the vehicle, it gives the alert to the driver. Similarly, post-accident reporting system, it used to intimate the accident details by SMS alert with the basic accident details to the nearby hospital or police station as well as the trusted contact. And third one is automatic road accident database updating system to update the road accident details automatically when a vehicle get an accident with basic record accident information in order to improve the accuracy of accident data collection. And all the hardware implementation is done with the street bikes, small engine scooters and bicycle. So the fourth objective is to perform empirical based testing of proposed model with the street bikes, small engine scooters as well as the bicycles. This is the block diagram of a project. I am already told that it consists of the distance-based pre-accident alert system, drunk and drive pre-accident alert system, post-accident reporting system, automatic road accident database updating system. So the distance-based pre-accident alert system consists of 4 ultrasonic sensors fitted in 4 sides of the two-wheeler and with the buzzer alert and LED alert. And similarly, the drunk and drive pre-accident alert system consists of MQ3 sensor, is nothing but a alcohol consumption measurement sensor. Again, it's also with the buzzer alert and LED alert. And third one is post-accident reporting system. So it consists of MPU 6050 vibration sensor and GPS module and also SMS alert service using the IFTT application. And the fourth one is automatic road accident database updating system. It consists of the ThinkSpeak cloud platform and web page development using Google Sites. So whenever a vehicle distance from the either side of the vehicle is too close means it gives the buzzer alert as well as LED alert to the driver. In drunk and drive pre-accident alert system, whenever a driver alcohol level consumptions will beyond the threshold means it gives the buzzer and LED alert. And post-accident reporting system, when a vehicle met an accident means in terms of vehicle acceleration as well as the vehicle orientation becomes abnormal means the vehicle met an accident means. So it detect the track the location of the vehicle where it happened the accident as well as it trigger the SMS alert service of the IFTT application to send the SMS alert to the contact person, trusted person. And all the sensors connected with the node MCU. It's a microcontroller. It's the node MCU. We use the ESP8266 microcontroller. It's the heart of this project. So all the sensors and other hardware modules connected with this node MCU microcontroller, and all the proposed model is tested on the two-wheeler in the real-time vehicles, scooty, bike and bicycle. This is the flow chart for the pre-accident alert system. So again, it consists of the two measurements. One is distance-based measurement and alcohol level measurements. So for the distance, we fit threshold value is 200 centimeter, that is 2 meter. So all ultrasonic sensor maximum up to cover the 4 meter. So we set the threshold value is 2 meter. So whenever a vehicle distance is below the 200 centimeter means it creates the buzzer alert as well as the LED alert. And alcohol level consumptions, we set the 300 ppm is the threshold value. So when driver alcohol level consumption is greater than 300 ppm means it creates the alert. This is the flow chart for the post-accident reporting system. So again, it consists of MPU 6050 vibration sensor. Here, 3 triggers are generated to detect the accident. So first one is the raw amplitude calculated from the accelerometer. So the raw amplitude value is greater than 5 means trigger 1 is activated. And if raw amplitude from the accelerometer is greater than 10 means trigger 2 activated. So once trigger 1 and trigger 2 is activated means Also, if vehicle orientation from gyroscope between 30 degree to 400 degree means trigger 3 will be activated. So once trigger 3 will be activated, so it means the accident detected. So parallelly, the SMS alert service of the IFTT application is triggered and also GPS location is tracked to locate the accident place. And finally, it is the automatic accident details updating system. So it consists of all the sensor values connected with the node MCU and also linked with the internet. So here the web-based database server, we used the ThinkSpeak cloud platform to automate and collecting all the sensor informations and stored in the ThinkSpeak cloud platform, and as well as the ThinkSpeak cloud data are in backgroundly processed with web page development using the Google Sites. The web page is specifically designed for accident details management using the Google site. These are the hardware requirements. So the first one is Node MCU ESP8266. It has the 30 pins including the GPIO pins and I2C interfaces, UART pins, PWM signals as well as the power supplies. It has the 5 volt power supply as well as 3.3 volt supply. And second one is the ultrasonic sensor. So ultrasonic sensor has the 4 pins. First one is VCC, trigger, echo and ground. So it has the transmitter and receiver. So transmitter transmit the ultrasonic waves. If an object comes in front of the ultrasonic sensor means again the ultrasonic waves is reflected and received by the receiver. So the distance time traveled between the transmitted waves and received waves is calculated and converted as a distance to measure the distance between the vehicles on the road. And the next one is MQ3 sensor. It's a alcohol detection sensor. It has also same 4 pins. So one is for analog output and digital out and power supply pins VCC and ground. It's a resistance based sensors. Whenever the alcohol level is increased, the respective resistance is increased and corresponding output is measured. And next one is for the MPU6050 vibration sensor. It has 8 pins. So we use the 4 pins to get the response from the vibration sensor: VCC, ground, SCL and SDA. SCL means serial clock and SDA means serial data. And next one is GPS module. We use the Neo ATM GPS module in order to get the fast communication and fastest tracking the location of the vehicle. And Node MCU have the limitations in the GPIO pins. It has only 9 pins for the specific digital IO read pins. So we need the GPIO pin expander module. So we use the 8 pin expander module PCF8574. And the next one is TCA9548A. It's the I2C multiplexer. So here we use the OLED display in the number of 3 OLED display with the same address. So we cannot directly connect the OLED display with the same address to the node MCU. So with the help of I2C multiplexer, we can easily connect the different OLED displays with the same address. And next one is the 5 volt buzzer alarm. Here we use it for creating the warning alert. And the last one is the power supply module. So for charging the entire module, we use the rechargeable battery with the specification of 3000 milliampere hour. This is the testing and calibration of each individual modules. So the first one is testing of ultrasonic sensor, and second one is testing of alcohol sensor, and next one is testing of vibration sensor as well as testing of GPS module. So in all the testing and calibrations are done in the breadboard connections, and we got the proper output. In case of testing of ultrasonic sensor, as I already told that you, whenever from the either side of the vehicle come closer to means the front sensor, back sensor, right sensor and left sensor measure the distances in front of the vehicles. So it gives the alert when it exceeds the threshold value. Similarly, in alcohol sensor, before starting the vehicle, if a driver drunk and try to start to drive the vehicle means it gives the pre-accident alert. And these are the experimental setup for testing the ultrasonic sensor. This is the front sensor, this is the back sensor, this is the right sensor and left sensor. This is a display for the distance-based pre-accident alert system with the measurement of distance of 4 sides of the vehicle, and this is the buzzer alarm and LED alert for the user. So all the sensors are fitted in the vehicle. This setup is for alcohol sensor for detecting the drunken drive. The person doesn't drink the alcohol means the alcohol level measurement is now 218 ppm. So it reads it is normal, you are safe. Likewise, it gives the display alert. If the person so the corresponding buzzer alarm and LED alert is in off condition. If the person drunk and start to drive means, so when the alcohol level is detected means now the alcohol level reached 1024 ppm. So it reads the it gives the it is danger as well as don't drunken drive alert. This is the testing of vibration sensor. So here it's the MPU 6050. It's a combination of acceleration as well as gyroscope values with the values of X, Y, Z for the acceleration as well as the vehicle orientation A, B, C. Here for the testing purpose, we read the temperature of the environment also. And in testing of GPS module, we connect the receiver and transmitter pin of the Neo ATM module with the microcontroller and track the latitude and longitude values. This video is taken for testing the vibration sensor. The sensor name is MPU 6050. It is the combination of accelerometer as well as gyroscope values measurement. That means acceleration in meter per second square and gyroscope values in radian per second. For the tilting angle as well as the rotation of the device where the sensor is fitted, it gives the corresponding values in X, Y, Z direction. As well as in this setup we read the temperature of the environment also. So this is the OLED display for measuring the acceleration and gyroscope values and temperature values. This is the vibration sensor. So the I2C device values is 0x68 connected with the Node MCU microcontroller. So the respective output of the vibration sensor is measured in serial monitor. When the sensor moved in any direction, so the corresponding values changed: forward direction, backward direction, front, back, top and bottom side. So the corresponding values in terms of acceleration, rotation and temperature values recorded in the serial monitoring as well as OLED display also. So this is the video taken for testing the GPS module. So this is the GPS module. This is the external antenna. After dumping the coding in Node MCU, we can see the output in the serial monitor with the values of latitude and longitude. So now by changing the location, so it also changed the corresponding values. So now again I am changing the latitude and longitude to somewhat other position. So it reads the values accordingly. Thank you. This is the overall circuit diagram connections for implementing the overall project. This is the hardware setup arrangements of the same whatever we are testing. We integrated all the individual components in a dotted board, and this is the hardware setup implementation for testing the our developed model. We implemented three product, the for one for the bike and for the scooty as well as for the bicycle. So all the products whatever we designed, it's properly worked. This is the results of a prototype model implementation. For testing our designed model, we use the model of similar two-wheeler vehicles. So for bicycle, scooty as well as the bike, this is the real-time implementation. The same setup is tested on the real-time vehicle also, bicycle, and Honda Activa model two-wheeler, scooty model, as well as the Pulsar bike. This is the results we obtained in the serial monitoring, the Arduino platform, as well as in the IFTT application of all the sensor modules. The collective informations of ultrasonic sensor values, alcohol level sensor values, and vibration sensor values. So when all the triggers, three triggers are activated, it means accident detected. So immediately it call the IFTT application website and create the SMS alert and send the message to the respective persons with the alert vehicle number and vehicle type. It get accident with the latitude and longitude value. This is the results of automatic accident details updating system. We use the cloud ThinkSpeak cloud platform to update the all the accident details as well as the sensor informations. So front side distance, left side distance, right side and back side distance, as well as the all sensor values and vibration sensor values. Is a time series database. For every 15 seconds, it will automatically update all the sensors informations to the cloud platform. We can see and download the reports anytime in this platform. Again, the location of the accident detected, all the tracking informations are stored, and this is the unique web page created for maintaining the accident details information. Here also we get all the sensor informations as well as the ThinkSpeak cloud platform is in background it's processed to the vehicle type based accidents in terms of number of bike accidents, number of scooty accidents, number of bicycle accidents, as well as the overall number of accidents. In addition to our research objectives, we done with the experimentation with the automatic vehicle tracking and monitoring system. With the we experimented this system with the 5 vehicles, including 3 cars and two-wheelers. That means bike transport. So in this, we can see the live tracking of individual vehicles with all vehicle related informations we can easily monitor with this system, like vehicle ignition on off systems and whether vehicle is running condition or in stopped condition, or if a single vehicle driven with the overspeed means it immediately it is notified to the monitoring platform, and whether the vehicle is in idle condition or unreachable condition. Likewise, all the status of the vehicle lively we can easily monitor. In addition to this, it has the applications including the dashboard, advanced dashboard, and advanced analytic dashboard, and live map tracking, and individual vehicle informations like speed of the every day-wise or month-wise, day-to-day historical informations of the individual vehicles like speed and total distance covered by the vehicle, and what is the locations of currently that traveled or previously traveled, the coordinates also we can easily monitor, and fuel consumption of the vehicle. Likewise, all the details of the vehicle informations we can easily monitor with the system. So we installed this for the 5 vehicles and monitored for the 1 month. Data are collected. These are the some informations related to the vehicle, like status of the vehicle, the ignition on off condition, or whether it is a ideal condition. Likewise, the graphical representation here we are displayed here. In addition to this, we can view the few reports also, like distance report, status report, travel summary report, stoppage summary report, idle summary report, sensor report, and speed versus distance. So this all the informations for the users can easily maintaining the vehicle as well as for the road safety also. Again, these are some reports taken from the same applications. So it's a conclusion of our project. So this study especially presented the prototype design and real-time implementation of accident prevention model for the two-wheeler users. So the developed accident prevention models include the distance-based and drunk and drive pre-accident alert system, post-accident reporting system, and automatic accident details updating system. All the developed models experimentally verified and also prototypally tested with the 3 type of road transports like bicycle, bike and scooty. So definitely we hope it will be useful for reducing the two-wheeler crashes in urban area as well as in rural area also. So the results outcome of this study provides great support for the police department and other road safety authorities to take appropriate actions against the road crashes without any further delay. And also the accident detail collection, that aspect also this developed model will be helpful for them. And this again it can be extended in future for other road transports like bus, van, truck, etc. These are the summaries used for implementing this project. And once again, I thank our college, Comrade College of Engineering and Technology, for providing the great support to complete this project in a successful manner. And also I thank the Institution of Engineers India for funding this project. Thank you.